All right, let's talk about factoring linear binomials. But before we do that, I'd like you to go ahead and do two quick distributions for me. Do me a favor and simplify 3 times 4x minus 5 and negative 5 times 2x minus 7. Do those and then come back to the video, so pause. All right, welcome back. When we distribute these, we should have 3 times 4x plus 3 times negative 5. Gives us 12x minus 15. And over here we have negative 5 times 2x and negative 5 times negative 7. So then we have negative 10x plus 35. What we're learning about today is factoring, which is effectively going to be taking something like this, which is already all multiplied out, and writing it as a multiplication, as a product. So you can think about factoring as sort of being like undistributing. It's sort of doing the opposite of distributing. Right? It's the opposite of distribution. So if we're asked to factor 6x plus 8, what we're looking for is what we can pull out to write it like a multiplication like that. So the key to being able to do this is going to be to identify what we call the greatest common factor. All right, what does that mean? Greatest common factor between the two terms. The greatest common factor, you're going to hear this a lot. We'll usually abbreviate it with just the letters GCF. The GCF is the greatest, in other words, the biggest number, but we're going to go ahead and use the word greatest, but in parentheses underneath if you want to. You can write biggest. It's not really the right word, but that's okay. The biggest number that's a factor of both terms. All right, it's a factor of the 6x and the 8. So what is that number going to be here? Well, it's going to be 6 has factors of 2 and 3. 8 doesn't have a 3 in it, so it has a 2 and a 4. We can take that 4 down to 2 and 2. Either way, what they have in common is a 2. So we've got a GCF of 2. So to write this in factored form as a multiplication, something where we have a number times a binomial, we're going to have that 2 on the outside. Then the question becomes what goes inside. 2 times what gives us 6x? Well, 2 times 3 would give us 6. So we need an x there to give us 6x. And then 2 times 4 gives us 8. So the factored form of 6x plus 8 is 2 times 3x plus 4. All right. For the next problem, we're going to look at negative 8x plus 20. Right? Go ahead and take a guess at this one. Pause the video, then come back. All right, welcome back. When we look at 8 and 20, we might see that there's a 2 in common, but they actually also both have a 4 in them, right? 8 is 4 times 2, 20 is 4 times 5. So we might be tempted to say that means that this is going to factor into 4 times, and then we would have 4 times negative 2x to give us this, and 4 times 20 to give it, 4 times 5 to give us 20. Now here's the problem though. This isn't wrong, but it's not a good answer. And it's not a good answer because we really prefer to have this first term, that x term, that variable term, we want to have that be positive. So rather than just factoring out a 4, which would leave me with a negative there, I'm going to factor out a negative 4. Because when I factor in a negative 4, then what I have to have here to get back to my original binomial is I have to have negative 4 times positive 2x to give me negative 8x, and negative 4 times, it would be negative 5 now, because a negative times a negative to get a positive would make positive 20. Right? I'm going to write down 6 more of these. I'd like you to try them on your own, and then unpause the video, and pause it where you need to see the solutions. So factor negative 6x plus 15, 10x minus 20, negative 7x minus 14, negative x plus 8, negative x minus 16, and the challenge problem at the bottom, 3 over 2x plus 5 over 2. Go ahead and pause the video, run through those, and then see if you got them right. All right, welcome back to the video. It's okay if you weren't able to finish all of them, but pause the video after each one to see if you want to change any of your answers or maybe finish some problems that you didn't. We'll start with this first one where the GCF is going to be, we could write it as 3, but because we want this to come out positive, we're going to write it as negative 3. So we have negative 3 times, it would be negative 3 times 2x to give me negative 6x, and negative 3 times negative 5, oops, sorry, that's not, yeah, that's right, to give me positive 15. On this next one, again, pause it if you haven't done it yet, we've got 10 is 2 times 5, but really, the greatest common factor between 10 and 20 is actually just going to be this 10, right? 10 is the same thing as 10 times 1, so I can factor out the GCF of 10, and I would have 10 times, let's see, 10 times what gives me 10x? Well, it would just be 10 times x, and then to get negative 20, I would have to have a minus 2 there. 10 times negative 2 is negative 20. All right, next problem, again, I'm going to factor out a negative to get that first term positive. So my GCF that I'm going to use is going to be negative 7. So I have negative 7 times, well, it would just be negative 7 times x to get me to negative 7x. And then it would have to be negative 7 times 2. Would it have to be positive 2 or negative 2? Well, it would have to be a negative times a to give me a negative. A negative times a positive gives me a negative. Well, this one's tricky because it looks like maybe we can't factor it. But remember, we want to have this first term become positive. So what I'm going to factor out, what I'm going to use for my GCF, is actually negative 1. That way I have negative 1 times positive x, and then it would be negative 8 to get me back to positive 8. Now this first term that I have here is a positive thing, and that was sort of the whole goal of factoring there. We're going to see the same thing happen this next one. Again, pause it if you haven't done it. If you have done it, it's going to be negative 1 times positive x, and then to get that negative 16, we're going to have positive 16. Right? The challenge problem, the one that I thought was a little bit of fun, maybe you're not quite sure what to do, but it turns out that what you can use for a GCF here, what you can factor out, is actually a 1/2, because this is 3 times 1/2, and this is 5 times 1/2. So we can write this as 1/2 times 3x plus 5.